Hello, everyone. Happy Monday. Hope everyone's doing well. Hope you had a wonderful weekend. It was beautiful and it was nice outside. Again, I'm always outside. I love spending time outside. Hopefully, you had a good weekend as well. Did you watch the video? Did you watch the video for this week? How many of you would actually be willing to do that? How much would they have to pay you to do that? I don't know. I don't think I'm scared of heights. I mean, I want to go skydiving sometime, but climbing up that tower would be insane. I don't know. I don't know if I could do it. But anyway, it's kind of interesting to watch if you watch the whole thing. If you haven't already, watch it. It's cool. But again, that does not count towards my half hour. Okay. All right. That's just separate. Okay. Quizzes. Hopefully, you guys are catching on. We're doing those quizzes every Friday. And for the most part, you guys did pretty well. Some of you let me know when things didn't quite work out, and I do understand there were some glitches on the quiz. We were trying to figure that out and work it out, but thank you very much to all of you who took it. If you struggled with it, please make sure you did the things I said on the email, because, guys, I'm going to be emailing anyone, you and your parents, anyone who is not doing well on those quizzes. So please make sure that you do it. Getting ready for the Friday, for the video the quiz this Friday as we get to that. Okay? All right, let's get started today. We're doing 931, graphing two variable inequalities. Your homework is 970 to 72. We're doing 931 in 2 days. This is the first day. Tomorrow we'll do the second day. Okay? Cool. You will need a pencil. You will need some graph paper. Yes, I do need you to have graph paper. So if you don't, please grab some right now. Yeah, it's, again, one of those things of if you do it, it's so much more powerful. If you don't do it, if you just watch very laid back and kind of relaxed, you're not going to catch as much as you need to. Okay, so please try to follow along with us and do the activity with us. Okay, here we go. What if the inequality has two variables? So graphing linear two-variable inequalities. In section 9.2, you learned how to use an inequality with one variable to help you solve a word problem. You also discovered that a one-variable inequality can have 0, 1, or more solutions, and that these solutions can be represented on number line. But what if the inequality has two variables? What is the solution to a two-variable inequality, and how could these solutions be represented graphically? Okay, how do I do that? Well, let's try it out. First problem. Okay, so think about this. Is the point -1, 5 a solution to the equation y equals -2x plus 3? And there's the equation right there. Okay. How could you tell by looking at the graph? Well, how would you know? I mean, I graphed y equals -2x plus 3. You see it's got a y-intercept of 3 and a slope of -2. Okay. Well, you could go to -1, 5 and go, oh, -1, 5 right there. Yay, it's on the point or on the line. It works. Okay. How could you solve using the equation? Well, the equation, I'd actually have to plug in the values here. And so I'd say 5 equals -2 times -1 plus 3. And -2 times -1 is +2 plus 3. Hey, 5 equals 5. That makes the inequality true, so therefore that is okay. All right? Or that makes the equation true, so that would be a point on the line. Okay? What about point 2, -1? Is point 2, -1 a solution here? Well, I go to 2, -1. Hey. Well, it does seem to be as well. How about point 0, 0? Well, 0, 0 does not seem to be a point on the solution. Now, it does say graph it, show it both on the graph and on the equation. Let's do that here. Let's see if I can squeeze some time here. I proved it there, but let's go with -2, 1. So, or 2, -1. -1 equals -2 times 2 plus 3. So -1 equals -4 plus 3. 3 and -1 equals -1. Yeah, that works. How about 0, 0? 0 equals -2 times 0 plus 3. 0 well, this is 0 plus 3. 0 does not equal 3, so that would not work. Okay? Makes sense. Pretty straightforward. Okay? Well, how about this one? What determines if the point is on the line? What is the difference between the point on the line and a point not on the line? Well, when I look at this graph, you should be able to note that any point on this line is actually infinite, millions of little points here, okay? All of those points, if plugged into this equation, will make the equation true. That's the key thing to address, right? It makes the equation true. So if it's on the line, it makes the equation true. If it's not on the line, it does not make the equation true. Cool? All right. Well, let's move on to the main problem here then. Okay. Graphing linear two-variable inequality. In problem 965, the problem we just did, you found that points on the line are the only points that make the equation y equals negative 2x plus 3 true. But what if you want to graph the solutions to the inequality y is greater than or equal to negative 2x plus 3? How will that graph differ from the graph of y equals negative 2x plus 3? Consider these questions as you follow the steps below, okay? And here's what you're going to do. Determine if the following points will make the inequality y is greater than or equal to negative 2x plus 3 true or not. And so what I'd like you to do is I'd like you to set up a graph right now on your graph paper. Just set up a graph. Please do it, okay? And graph y equals negative 2x plus 3, which would give you this line here. And then you're going to look at these points right here, and I want you to actually plug them in or check them on, well, plug them into the inequality and see if the inequality, if those points make the inequality true. If they do, I want you to plot the point. If they don't, I want you to not plot it, okay? So we're just plotting the points that make the inequality true. Cool? All right, so please pause the video. It'll take you less than 5 minutes, okay? Please pause the video. Again, it's powerful. It really is helpful here. Please pause the video and figure out what points make that inequality true. When you're done, unpause it, and we'll check. We'll compare it, okay? Cool. Pause. Do it. Come on. All right. Hopefully you paused it. Hopefully you did it. And hopefully you've noticed something, okay? If you did it, I feel like just not even showing you and just making you do it. Hey. Okay. Well, let's see. Will point negative 2, 3 work? No. Point negative 2, 3 does not work. How about point 0, 3? Yes, point 0, 3 did make that inequality true. How about point 2, 5? Yes, point 2, 5 did make that inequality true. How about point 3, 1? Yes, point 3, 1. Oh, yikes. Point 3, 1 did make it true. How about point negative 1, negative 1? Negative 1, negative 1 did not make that true. How about point 1, 1? Yes, point 1, 1 made the inequality true. Point 0, 0? No. Point 2, 0? Yes. Point negative 3, 0? No. Okay. Now, if we had done this in class, there would have been a lot more points. I didn't make you do all of them. But I do want you to notice several things. By looking at the graph, you can already get some ideas, okay? There's some questions we're going to answer now based on this, okay? Now, had we done it in class, you all would have gotten some, and you would have come up and put stickers on a board, on a graph on the board, to identify whether they're true or not. So just where it says stickers, identify dots, okay? Are there any points on the graph that you suspect are solutions but do not have a sticker? Well, you hopefully do. Are there any stickers that you think may be misplaced? Well, hopefully not. Hopefully I did okay on these stickers, but I think they should be fine, okay? What about the points on the line? Are all the points solutions to the inequality y is greater than or equal to negative 2x plus 3? Why or why not? Well, think about that. Are points on the dot or on the line solutions to this inequality? And if so, why? Well, remember that any point on the line make the equation true. Well, this one does have an equal, so therefore any points on the line would make the inequality true. Okay? How many solutions are there? Well, actually, ladies and gentlemen, how many do you think there are? There are an infinite number of solutions. Why aren't any of the solutions located below the line? Well, hopefully you notice all of these points here were down here. All of the solutions were up here. Okay, these all were good solutions, and any points on the line. All of this did not work. Okay, so we're looking for, I know that was kind of, I don't know what I'm doing there, shading, but whatever, you get the point. All the solutions seem to be on this side. any point on any coordinate point. You take any coordinate point on this side of the line and plug it into this inequality, and it'll make it true. Cool? All right. So that is what I want you to focus on. Now we got one more problem we're going to do here. Okay? Here we go. What else can you learn about solutions of linear inequalities? Well, think about this as you answer the questions below. Now, do you notice what they did here? The shaded portion here, shaded portion represents a side where the solutions come from. Okay, so you know anything on the shaded side is, so we don't just draw a line, we actually shade it in. Now, as you are shading these in, I do want you to make the graph. I want you to actually shade your solutions. Please don't shade very hard, because if you shade very hard, it kind of covers up the line, and later on we're going to do some work where you need to do more shading. So please shade lightly, but shade enough to where you can actually see it. Okay, so what if the graph were shaded like the one on the right? What inequality would correspond with that graph? So please make a sketch of this graph on your paper. Sketch this graph on your paper with the shading and everything, and then tell me what the inequality would be. Cool? All right. Well, as you notice, we have y and we have negative 2x plus 3. So we still have that. Okay? Now, what would the symbol be? That's the key thing. Now, if you notice carefully, everything below is shaded in. That means, well, if for the previous problem was the part was shaded above, and it was y is greater than or less than, or greater than or equal to, this would be less than. Okay? Now, we have the solid line there. And so it would be less than, we got the line there, so it would be less than or equal to negative 2x plus 3. Okay? But then Heidi asks, what if I change the inequality to y is less than negative 2x plus 3? Now what would the graph look like? And I gave you a hint if you just heard me. That should give you a pretty good idea of what was going on here, okay? So if I do not have this less than or equal to, if I just have a less than or greater than, I am still going to have my sketch and I'm still going to have my shading, but my line, do the points on the line work? Not anymore. So if they do not work, how do you think I could show that? Any guesses? Think about it. Well, if you guessed a dashed line, you would be correct. Okay? So I would dash the line with the arrows and I'd shade in the side. So y is less than negative 2x plus 3 would look like that. Cool? So if it's greater than or equal to, or less than or equal to, it's a solid line. If it's just less than, it would be a dashed line. All right? Okay, that is the start of graphing two variable inequalities on a two-dimensional graph. Okay, so your homework is to do lesson 931, day 1, problem 70 to 72, 70, 71, 72. And give it a shot. I want you to do your best on these problems. Tomorrow you see the answers. Please do them on graph paper because I want it to be accurate, okay? And yeah, have a great day, guys. I will see you tomorrow, okay? All right.